What if I told you that your smartphone, the device you check every few minutes, only works because of the weirdest rules in the universe, quantum physics? Without electrons behaving like waves, or sometimes vanishing through barriers, your apps, your camera, your GPS, everything would be impossible. Today, I'll pull back the curtain and show you the quantum magic hidden inside your pocket. I am Frederik Christiansen. Welcome to my channel. If you are new to the channel, then this is your go-to if you want awesome science knowledge that has a direct impact on your everyday life. Today on how quantum physics are driving your phone, minus the jargon and equations. If you want more awesome science videos like this, then hit that subscribe button and of course the bell so you will never miss out on any videos. Moving on, at the heart of your phone are billions of transistors, microscopic switches that turn on and off billions of times every second. But here's the catch. Normal, everyday physics can't explain how these switches are so tiny, fast, and reliable. To understand that, you need quantum mechanics, the science of the very, very small. Quantum physics tells us that electrons can only exist at specific energy levels relative to the nucleus of their atom. You can think of these levels a bit like the orbits of planets around the sun, except in reality, electrons don't follow neat paths. Instead, they form fuzzy clouds where they're most likely to be found. Each of those clouds represents a different amount of energy, and that's what we call an energy level. And notice I said where they're most likely to be found. That's because electrons can jump between these energy levels, moving up when they gain energy and falling back down when they lose it. When an electron absorbs energy, like from heat or electricity, it can jump to an energy level further away from the nucleus of the atom. But when it falls back down to an energy level closer to the nucleus, it releases that extra energy as a tiny particle called a photon, which is just the scientific name for a particle of light. In other words, when an electron falls from a higher energy level to a lower one, it gives off light, and that light, those photons, are what create the colors and brightness you see on your phone screen. Every pixel on your display depends on these tiny quantum jumps happening billions of times per second. But for those photons to actually display something meaningful on your screen, we can't just let this process happen randomly. And that brings us back to quantum probability, to the question of which energy level an electron is most likely to be found at any given moment. So, back to the energy levels. They're separated by empty space in between, and that space is called a band gap. When an electron jumps from one energy level to another, it has to cross that band gap. The width of this gap depends on the material made up by the atom. In metals, the band gap is extremely narrow, so electrons can move freely between energy levels. That's why metals are excellent conductors of electricity. In materials like rubber, the band gap is very wide, meaning electrons can't cross it at all. Because of that, rubber can't carry electrical current. Therefore, it is known as an insulator, not a conductor. In order to control how electrons jump between energy levels, we need a material with a band gap that's just right, not too narrow and not too wide. Materials like this are called semiconductors. By default, a semiconductor doesn't let electrons jump freely between energy levels, but its band gap is narrow enough that we can manipulate it by adding energy, light, or electrical signals to let electrons cross when we want them to. You can think of this like a drawbridge that can be lifted or lowered. This gives us the ability to control if electrons are allowed to jump down to a lower energy level, releasing a photon in the process. In this way, your phone can produce light exactly where and when it is needed to display meaningful content on the screen. That ability to control when electrons can and can't move is what makes semiconductors so powerful, and it's the foundation of every electronic device you use. From invisible quantum jumps to the glow of your screen, your phone is proof that the weirdest science in the universe works flawlessly in your hand. If you enjoyed this video, please hit the like button. It really helps out. And remember to subscribe if you want to understand how the complex science behind our universe actually connects to your everyday life. Without the boring jargon, I'm Frederik Christiansen, and you've been watching Geeka Nerdy, where everyday life meets awesome science. Take care and stay curious.